In this example, we're going to practice finding the derivatives to answer a couple of questions. So the first, we're given the function f of x equals 3x cubed plus 2e to the x. And for part A, we're asked to find what f prime of x equals. And so we have lots of rules that we're reviewing, and what the good thing about this chapter is we're constantly going to be practicing the previous section's rules. So this is from the previous section, and the constant multiple rule, what the derivative of x cubed is, and the fact that when we have two things added, we can still find the derivative of them by adding each of the separate derivatives. So lots of rules that we're practicing here. To get that f prime, I'll write things out carefully, even though sometimes you might do this in your head, would be 3 times the derivative of x cubed, I'll put that in parentheses, 3x squared, and then plus 2 times the derivative of e to the x. And we saw that the great thing about our natural exponential is the derivative of e to the x is just e to the x. So simplify. We have f prime of x is 9x squared plus 2e to the x. In part B, we're asked to find the tangent line when x equals 0 to this graph. So what we have to remember is that slope of the tangent line equals the derivative at that point. And it's not the derivative in general, it's the derivative calculated at that point. So it's not that the slope equals this. We care about it at x equals 0. So we're going to get m is going to be, our slope of our tangent line is going to be the derivative when x equals 0. So when we do that, we're going to get 9, I'll write things out carefully, 9 times 0 plus 2 times e to the 0. And remember, 2 times e to the 0, that equals 1. So we have an answer of using the slope, m is going to be 2. Now another part of this problem is they only gave us the x value of the point we care about. So we need to use for our point is going to be when x equals 0 and the point on our original function, f of 0. And when we plug in 0 into our original, we get the point 0, comma 2. So lots of 2's going on with this problem. So this is the point that we use, m equals 2. Several ways we can do this. One is using our point slope form of a line. Y minus 2 is going to be 2 times the quantity x minus 0. So when we do that, simplification, y minus 2 is going to equal 2x. If they asked for it in mx plus b form, we would simplify it to get the equation of the tangent line is y equals 2x plus 2. And if we graph this in Desmos, we can graph the original function and this, we can see that this is indeed the tangent line. All right, so we're in Desmos and we have graphed 3x cubed plus 2e to the x. And then we had figured out that the tangent line is y equals 2x plus 2. and we want that to be tangent at the point 0, 2. So we can see that it is indeed tangent to the graph of the 3x cubed plus 2e to the x right at the point when x equals 0.